We're trying to evaluate the energy of cyclohexane as my example. I start up GaussView. Gives me a little tip or something that I close. There's two windows. The gray background window is where the pieces of the model kit are located, and I'm going to bring them in to the blue background window with a single click. There's templates up here. The first one brings up the periodic table, so you could pick any kind of atom from any element. The second one brings up rings. So if you want to begin by clicking on the cyclohexane ring, that's a good starting point for this problem. I can move it around on the screen by holding down Shift and using the left mouse. I can rotate by just using the left mouse. And I can zoom in and out using the wheel. Look, I can make it go way far away, or I can bring it all the way in. Okay, enough of that. Here's my cyclohexane. If I want to make chlorocyclohexane, I'll have to pick axial or equatorial. I think I'll do axial first. I can click on the carbon icon for a periodic table, choose chlorine atom, click, and I've made chlorocyclohexane. I can use the little broom, clean it up. I can even symmetrize it by hitting the symmetry button. And that'll just make anything that should be equivalent. And there's axial cyclohexane. I'm ready to calculate. I do the calculation setup. There's tabs in this box window here. The first tab is job type. I choose optimization. I do that because I want the program to move the atoms so that they're the optimal position. Right now, I've just got a sort of a guess at the structure. I've got things connected right, but I don't know if all of these bond distances and angles are good. And the job type optimization fixes that. The method we'll choose under Hartree-Fock, we'll choose density functional theory. B3 lip, that's there already. And then basis set 631G, and then in parentheses, D. These choices are echoed up above in the keyword section. You can see it should say opt, B3LYP, 6-31GD. And title, I'm doing axial chlorocyclohexane. And in the link 0, I pick 4 processors to make it go as fast as I possibly can go, because I don't want to have to wait any longer than I have to. And I submit. When I say submit, it's going to ask me to locate the file somewhere. Best place to put it is on the C drive in the temp folder. And you have to give it a name. No funky characters here, no spaces, please. It should just be letters. You can use underscore, right? So CL, I'll put axial, I'll put ax for axial. Axial hyphen chloro hyphen checks. The name of the file is up to you. It should tell you what this is, though. And so here, by naming it AXCL checks, I know exactly what it is. And then it should be off and running. So the handout shows you the 4 structures that you need to evaluate. And then I show you how you should set up the Excel with the table. You'll put in the 4 numbers, compute the difference, and then the other thing you can do is paste images in here if you want from GaussView so that we have a picture.
I have a question.
Yes, go ahead.
So like the equatorial versus the axial, that just depends on where we put the chlorine atom, right?
That's right. That's right.
There isn't any special buttons we have to hit for that. We just put it on top or on the side.
Yeah, you'll click on the hydrogen, having picked the chlorine atom to replace it.
Okay.
So we go and get chlorine, and we can choose just the chlorine atom, and then click on the hydrogen that we want to replace. There's the equatorial one. Here's the axial one. Whoa.
Okay.
I just wiped out the whole thing. Why did I do that? Okay, there it is. If you make a mistake, it's pretty easy to fix. There is an undo, Control Z, or edit undo, or click on this little curvy arrow thing. So you can, if something happens, you're like, whoa, I don't like that, you can always just step back by undoing. And then remember the other things I showed you. If you need to delete an atom, there's this little X with an atom attached. If you need to add a hydrogen, there's this hydrogen with an atom attached. If you need to draw in a bond, there's the bond tool. Those are all in the second row about the middle of the control panel. Here's my completed Gaussian job. I'm going to look at the log file, and under results, I can find a summary that gives me the energy. And there, so I did the axial chlorocyclohexane, so this is the same number that you should get for that. I can copy that, Control C, and then paste it into Excel and label it. And then to do the next one, I would just delete that, add it back to hydrogen, and then put it equatorial. And I'm all set to do the second one.
I have a quick question for you about inserting the picture into Excel.
Okay.
How would you do that?
Let's see, there's probably more than one way to do it, but this is a general thing, right? If you have in Windows something on your screen, you can always click the print screen button on your keyboard. Print screen. You can paste it into Paint and then select just what you want and copy and paste. So again, if you didn't catch that, if you want a quick way of getting a picture of the molecule onto your spreadsheet, just have it positioned here the way you want it, and then hit print screen on the keyboard. And then you can go to Paint and paste that in, and then select just the molecule, copy it, and paste it into wherever you want to paste it. Could be Excel, could be Word. Quick way to snag something off the screen and put it into your report. that's just a static image. We're going to learn something really cool, I think the next time we meet, and that is you can actually snag the 3D model and put it into your document so that you could rotate it and everything even after you pasted it into Word or on, put it on the web. We're going to see how to do that next time.